Welcome my dear student. Welcome to my channel Physics JN. That is the channel specially made for joint and NEET. तो आज हम लोग बात करेंगे कैलोरीमेट्री और हीट ट्रांसफ़र के बारे में। तो ये दो एक ही चैप्टर है, कैलोरीमेट्री और हीट ट्रांसफ़र। तो आज हम जानेंगे प्रिंसिपल ऑफ कैलोरीमेट्री। सो बिफोर गोइंग द प्रिंसिपल ऑफ कैलोरीमेट्री वी कैन लर्न सम न्यू टर्म अबाउट फेज चेंज. You all aware that phase change is nothing but change of solid into liquid and liquid into solid. So why phase change takes place? When a heat is added to some substance, its temperature will change. That is, it may be increased or decreased. But there are some certain conditions in which, in spite of heat is supplied, the body does not change any temperature. This is known as phase change. So, in phase change, the temperature of solid does not change, but its physical characteristics, that is, solid is melting into the liquid. This process is known as melting. In the similar way, a amount of heat delta Q is given. In the similar way, the liquid may be converted into vapor. The process is known as boiling. The reverse process is also occurred. So, we can know that in this case we do not use the equation Q equal to ms delta T, because here there is does not change in temperature, so delta T is 0, so Q must be 0, but Q is not equal to 0. So the heat given in this process is called latent heat. Latent means hidden. Why it is hidden? Because it does not occur any change in temperature and it does not measure by thermometer. So it is called latent heat. There are generally we deal with two types of latent heat. One is latent heat of fusion and other is latent heat of fusion, other is latent heat of vaporization. So latent heat of fusion of ice is 80 calorie per gram. In SI it is 336 kilojoule per kg. And the latent heat of fusion of water is 540 calorie per gram or 2260 kilojoule per kg. So the latent heat of vaporization, this 80 calorie per gram is called latent heat of vaporization. We can term it as LV. And 540 calorie per gram is known as latent heat of fusion. It is LF. And this is latent heat of vaporization. You can see here that the latent heat of vaporization is greater than latent heat of fusion. The question is why? Because when the solid get converted into liquid, its volume change is negligible. But when a liquid converted into vapor, its volume change large. So it takes more amount of heat. Another question is why latent heat does not measured by thermometer? Because in solid the molecule or the intermolecular force is very large. But when it's melt, that is, it converted into liquid, it has to do some work against the intermolecular force, because we know that In liquid, the intermolecular force is weaker than solid. In gas, the intermolecular force is least. So, when a solid can gets converted into liquid, its intermolecular force is weak, and we have to do some external work against the intermolecular force. So, we have to supply some heat from the outside. We supply a heat from the outside. It increases its internal energy, that is the sum of its kinetic and potential energy. We know that for ideal gas, the energy is only the potential energy, there is no, the energy is only kinetic energy, there is no potential energy. So the heat given from the outside is only increase its internal energy. So it does not get measured by the thermometer, it does not change any temperature. Now we go with temperature and time graph, temperature time graph. So and in the last of the video we shall do numericals for NEET. So we go with temperature time graph. If we plot a graph time and temperature, then if the substances of solid, if the solid has a temperature less than its, if we take in the case of ice, then the substances has temperature less than 0 degree, then suppose this is minus 10 degree centigrade or minus 20 degree centigrade at the initial. So we can get this type of curve and so on. We can write it as A, B, this point is C, this point D, and this E. There are two certain temperature occurred corresponding to B. The temperature we know that it is given by T1, corresponding to the point D it is given by T2. And the time, if we draw this in this type, this is the time axis. So the B1, the time is take T1. For C, the time is T2. For D, we can take the time as T3. Okay, A, B, C, D, E is here. For E, the time is T4. So, what represents AB? When the temperature of ice is minus 10 degree centigrade, if we supply heat from outside, at first it will get converted into 0 degree centigrade ice, minus 10 degree centigrade to 0 degree centigrade. So for portion AB, for the AB portion, the specific heat is inversely proportional to the slope of the given light. If we take the slope, that is the total energy Q here equal to M, S and delta T. Now what is Q? Q is the form of energy. So we can write it as P delta T equal to M, S delta T. P is the rate of energy supplied. So if we take the slope means this slope is delta capital T by delta small t. Sorry, here P into delta T, here this is delta capital T. We can write it as change in temperature. So delta capital T by delta small t, if we get, so we can get that it is 1 by P M in S. That is, it is inversely proportional to the S is the specific heat. So slope is inversely proportional to the specific heat. Here the temperature change occur. that is minus 10 to T1. What about the line BC? At the line BC, there is no change in temperature. Between the time T2 and T1, the temperature change is same. So in this case, we can get Q equal to M times LF. So here the slope of the line is, so the amount of heat is proportional to the slope is 0. Here the slope is 0. Here slope is 0. Here slope is 0. So here heat is proportional, directly proportional to the length of the line. Length of the line is BC. So if the length is increased, then more amount of heat is required. If the length is small, less amount of heat is required. So that is the time elapsed. If a small amount of ice bar is taken, then the time is large, heat is large, and the vice versa. So heat is proportional to the length of the total line. And here the slope is 0, so the specific heat Cs is inversely proportional to slope, that is 1 by tan 0 equal to infinity. Here specific heat is infinity. The similar case occurred for CD. For CD, the specific heat is inversely proportional to the slope, and for DE, the slope is 0 and the heat is proportional to the length of the line. So this is text. So at T1, the ice starting to melt at its melting point. T1 is known as melting temperature or melting point. T2 is known as boiling point. Okay. And at B, the ice starts to melt, and at C, the ice is totally melt. So in the between B and C, there is a mixture of solid and liquid. There is a mixture of solid and liquid, because here ice starts melting. Okay, and till C, the temperature is constant and ice is totally melting liquid. At C, the all is liquid. Then increase the temperature till D, and at D it's start to vaporize. In the between portion, this is a mixture of liquid and vapor. At E, the all liquid transfer into vapor, and then if we supply heat from outside, it is again increase temperature till EF. So this is we can say this is the temperature versus time curve, which is very, very important for your upcoming NEET exam. Now we go with, I hope you will know the phase change very well. Now we will go with the principle of calorimetry and do numericals. So don't skip, don't go anywhere, stay tuned and clear your doubt or any other difficulty. Next we will go with principle of calorimetry. I know you know this, you will read it in the board exam or in the lower class. Principle of calorimetry. So if there are two bodies, one is hot body at temperature θ1 and one is lower body, so this is hot body and this is cold body, temperature is θ2. So if we mixture hot body and cold body, the hot body becomes lose heat, that is the heat transferred to the cold body, and the cold body gain temperature. then they both reaches at a temperature which is lower than hot body but higher than cold body. So theta mixture is greater equal to theta cold and theta hot is greater equal to theta mixture, because nobody can be so cold that theta mixture may be lower than theta cold, and anybody can be so hot that it's overcome its initial temperature. So the mixture temperature must be greater than the cold body and lower than the hot body. If hot body have initial mass m1 and specific heat is s1, and this is initial mass m2 and specific heat s2, then according to principle of calorimetry, when they reaches in thermal equilibrium, that is the temperature, both the temperature is theta mixture. So according to the principle of calorimetry, heat given must be equal to heat taken. Okay, so heat given by hot body is m1 s1 theta minus or theta 1 minus theta mixture is equal to m2 s2 theta mixture minus theta 2. We can find out theta mixture from here. m1 s1 theta 1 minus m1 s1 theta mix equal to m2 s2 theta mix minus m2 s2 theta 2. So we can write here as m1 s1 theta mix plus m2 s2 theta mixture must be equal to m1 s1 theta 1 plus m2 s2 theta 2. So theta mix must be equal to m1 s1 theta 1 plus m2 s2 theta 2 divided by m1 s1 plus m2 s2. This is the very important formula for doing numericals in the upcoming NEET or JEE exam. You can do numericals directly from this equation. This is very easy chapter but very important chapter. Okay, so now we go with some numericals. Number 1 numerical is 50 gram of ice at 0 degree centigrade, 50 gram of ice at 0 degree C is mixed with 50 gram of water at 60 degree centigrade. What will be the final temperature? Final temperature. You will be given 4 options. So do it on in your copy. Here we cannot say directly that if you think that 50 gram of ice at 0 degree centigrade, let us the temperature is theta, then the temperature of water, that is 50 into 1, here specific heat of ice, sorry, S ice is given as 0.53 and specific heat of water is given as 1 in CGS, that is calorie per gram degree centigrade. So if you think that 50 into 1 into 0, that is theta minus 0 must be equal to 50 into water into 60 minus theta must be equal to 50 into 0.53 into theta minus 0, then the sum will be incorrect. Because at first what happened we shall think. क्या होता है इसको समझना चाहिए. 60 डिग्री सेंटीग्रेड में वाटर है, वाटर 50 ग्राम वाटर है 60 degree centigrade. So when you add ice in this, it will lose temperature, lose heat, and it becomes going to 50 gram water at 0 degree centigrade. So what amount of heat loss? Heat loss is given by MST. M means 50, S is 1, and T is 60 minus 0. That is 3000 calorie. 3000 calorie. Now 50 gram of ice. So the mass of ice melt, because when water is added to ice, it becomes gain heat and it will becomes melt. So the mass of ice melts is total heat, that is 3000 divided by its mass, that is 50. Okay. ML, no, sorry, 3000 divided by 80, not 50, because Q equal to ml. So if we find mass m, then Q by L equal to m. L is 80 for latent of fusion. So if we divide 3000 by 80, we can get that 8 2 sorry 37.5. So if the water loses heat 3000 calorie, to convert its temperature from 60 to 0, all the ice becomes melt, because 37.5 gram ice is melt. 37.5 gram ice is melt, but the ice is 50 gram. We know that when the total solid, total substance does not get to liquid completely, its temperature become fixed. So the amount of whole ice is 50 gram, but if it is takes heat from water, the amount of ice melt is 37.5 gram. So there is 12.5 gram ice is still to melt. So the temperature remains at 0 degree centigrade. So the final temperature, what will be the final temperature? Answer is 0 degree centigrade. If whole ice will be melt, then its temperature increases or becomes any other final temperature. As there is no, as the whole ice is not melt, so the temperature become fixed. We know the melting point of ice is what? 0 degree temperature. So the final answer will be 0 degree temperature. I hope you understand this. Next we go with similar problem but with other criteria. Numerical number 2. An iron ball of mass 0.2 kg and iron ball of mass 0.2 kg is heated to 100 degree and put into a block of ice at 0 degree centigrade. Is heated to 100 degree centigrade and put it on an ice block so hot. Ice block at 0 degree centigrade. At 0 degree C. 25 gram of ice melts. Here the amount of ice melts is known. 25 gram of ice is melts. 25 ग्राम आइस पिघल गया है. If the latent heat of fusion of ice is atto, then the specific heat of iron is. If the latent heat of fusion of ice is 80 calorie per gram, then find specific heat of iron. So we know that iron ball of mass 0.2 kg is heated to 100 degree centigrade. When the iron block is put into ice, its temperature becomes 0 degree centigrade. So heat given or loss by iron must be equal to heat taken by ice block. Heat lost by iron is MST. M 0.2 into 10 cube, that is it is kg. We convert it into gram. So M S we have to find out. Delta T means 100 minus 0 must be equal to the 25 gram of ice, that is ml. So we can write M 25 into 80. Here Q1 equal to Q2. The Q1 is ms del T and Q2 is ml. I hope you understand. From this we can easily find out S, that is the value of S will be 25 into 80 divided by 0.2 into 1000 means 200 into 100. So 25, 8, 10, 10. 0.1 calorie per gram degree centigrade. So the specific heat of iron is 0.1 calorie per gram degree centigrade. This is the another type of mathematics. And if the water ice problem, if the ice is total melt or water is totally vaporized, then its temperature will further increase. In that case we have to take in the total heat as ml plus mst. But if the total ice does not melt or total water does not vaporize, it will be remain at the temperature. For ice melt it is remain at 0 degree centigrade and for water vapor it is remain at 100 degree centigrade. So आज के लिए बस इतना ही. अगर आपको मेरा वीडियो अच्छा लगता है तो लाइक कीजिए, चैनल को सब्सक्राइब कीजिए फॉर फर्दर इंटरेस्टिंग वीडियो. डियर स्टूडेंट, थैंक यू वेरी मच.